Acceleration. Acceleration is the rate of change of velocity. So basically, what we did for this chapter was we started off with displacement. Then if you differentiate displacement with respect to time, we get velocity. Now, if we differentiate velocity with respect to time, what we get is acceleration. Okay, so we are trying to look at how fast the velocity of an object is changing at a given point in time. Okay, if you look at this diagram here, it is said that at this point here, velocity is equals to 3 times t. Here, velocity equals to 3. It's moving at a constant velocity. Here, the velocity is given by this function here. So now, if you recall what we have just did like a few moments ago, the acceleration is you will take the differential of velocity with respect to time, so you get 3. Notice it's positive 3, so that means any time along this point, along this from 0 to 1 second, the acceleration of the object is 3 meter per second square. Okay, now when velocity is constant, it means that there is no change in velocity. So if you were to you differentiate velocity with respect to time, you get 0. And this makes perfect sense because the acceleration is 0, because the velocity is constant, there's no change, so acceleration is 0. Now for the very last part here, if I differentiate velocity with respect to time, I get negative 3/4. Okay, and notice that, right, acceleration in this case is negative. Negative will imply that the object is slowing down until it reaches this point here where the velocity is 0. It means that the object is at rest itself. So if acceleration is positive, the particle is speeding up. Acceleration is 0. Particle is moving at a constant velocity. So be careful here. Acceleration equals to 0. It may mean that the object is at rest, or it also can mean that it's moving at constant velocity. It does not mean that the object is confirmed at rest. Okay, so when acceleration is 0, it's just that there's no change in velocity, so it could be moving at a constant velocity. If acceleration is less than 0, it means that the particle is slowing down. Okay, there's deceleration. Now, example 2. The particle is moving a straight line, so that at any time, the displacement is given by 2e to the power of negative t sine 6t. Find the value of t when the particle first returns to O. Okay, first returns to O means that the displacement is equal to 0. Why 0? Because at O, the starting point, the displacement is 0 itself. So to solve part 1, what I have is I let my displacement s equals to 0. So this is equals to 0. Then what I have is 2e to the power negative t equals to 0, or sine 6t is equals to 0. For this, right, e negative t is always positive. Go and revise how the graph looks like. So right, I have nothing here to solve. Okay, so what I'm going to solve here, is this portion here, sine 6t. So where is the sine graph is equals to 0. Sine graph is equals to 0 at 0, pi, 2 pi, and so on and so forth. So t, 0 divided by 6 is 0, pi over 6 seconds, pi over 3 seconds, etc. So t goes to 0 is where it started. Then after that, it moves and it come back. At what time does it return to the origin? All right, it returns to origin at pi over 6 seconds. Hence, for part 1, first returns at t equals to pi over 6. Okay, for part 2, the particle first comes to instantaneous rest. So you have to learn to identify these terms. Instantaneous rest means that v is equals to 0. Hence, what I can say is that velocity is equals to ds dt is equals to 0. Now, what I need to do is to differentiate this. So if I want to differentiate this, okay, it's very obviously a product rule. So u is equals to 2e to the power of negative t. Differentiating u with respect to t is negative 2e to the power of negative t. V is sine of 6t. Differentiating v with respect to t is sine differentiated becomes 6t. You differentiate the 6t, you put the 6 out front. So therefore, ds dt goes to, we apply the product rule here, v du dt, so negative 2 e negative t sine of 6t plus u dv dt. So it's 12e negative t cosine of 6t. So what happens is I will factorize, okay. What I can factorize here will be 2e negative t, 2e negative t. So I'm left with is negative sine 6t plus 6 cosine of 6t. Then for instantaneous rest, the velocity is equals to 0. So what I'll say is 2e negative t, 6 cosine 6t minus sine of 6t is equals to 0. Then 2e negative t equals to 0. There is no solution. Okay. Why there's no solution? Because e to the power negative t is greater than 0. Okay, for all real values of t. Hence, okay, what I need to solve is 6 cosine 6t minus sine of 6t equals to 0. So what I can do here is this. Remember this trick here. Sine of 6t is equals to 6 cosine of 6t. If there is a sine and a cosine and only a sine and a cosine, you divide both sides by cosine. So sine 6t over cosine 6t. You can eliminate. This guy becomes tangent of 6t. So what we get here is tangent of 6t equals to equals to 6. Alright, so if you have 6, you inverse tangent of 6. Okay, what you get here is your alpha inverse tangent of 6. What you get is 1.4056. Okay, then what we have here is, since tangent is positive, you occur in the first quadrant and the AST third quadrant itself. So what I can say here is 6t is equals to 1.4056. That's the first quadrant. In the third quadrant is pi plus 1.4056. Therefore, if I divide both sides by 6, the t value is 0.234, okay, and 0.758. So therefore, find the first comes to instantaneous rest. So if first comes to instantaneous rest here, then it comes to instantaneous rest here again. So therefore, to answer this part 2, okay, the value of t is equals to, so at A, okay, t is equals to 0.234. Now, part 3. Find the acceleration of the particle at A. So previously, what we have is the velocity is given by this whole chunk here. So let me just copy this out. Okay, then let me paste this here. Okay, this is going to get a bit what I call complicated, but just follow. Okay, it'll be fine. So do you remember how we get acceleration from velocity? That's right. Okay, we will differentiate velocity with respect to time to get the acceleration. Okay, this is one huge chunk here. Let's slowly do this. Okay, there are two parts here. There you will have to use product rule. So there's one term here, there's u. Okay, then there'll be another term here. I will call this guy v. Okay, so if u is 2 to the power of e to the power negative t, du dt is negative 2 e to the power negative t. V is equals to negative sine of 6t plus 6 cosine of 6t. Differentiating v with respect to t will give me sine differentiated gives you cosine. Then you take out you differentiate 6t, you get negative 6 cosine of 6t. Cosine differentiated gives you negative sine. So, and then you differentiate 6t, so you get negative 36 sine of 6t here. So therefore, the acceleration is given by v du dt plus u dv dt. Okay, like this. All right. Now, I will really suggest that you don't go and try to simplify or anything. So now, okay, what you can do is you just say that you let your t equals to 0.234. Because at A, the value of t is 0.234. What you can do is just use your calculator, just plug in the t into here, 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 and here. So if you press the calculator and everything works out fine, your acceleration is equals to negative 57.8 meter per second square. So basically, right, it is slowing down. Okay, try to pause the video now, okay, and try to, when you're ready, you can unpause and I'll give you the explanation for try to. Okay, first returns to O. And first returns to O means that displacement is 0. So this portion here is first returns to O. So at O, the displacement is 0. So if we solve, 2 sine 3t is equals to 0. Solving, okay, sine 3t is equals to 0. Inverse of 0, okay, where is the sine function 0? Is at 0, at pi, at 2 pi, dot, 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 dot. So you divide by 3, okay, you get 0 and pi over 3. Hence, at 0 is where it started. So when it will go at time equals to 0, is at the point O. It will move until the time pi over 3. Sorry, not pi over 3. There's a certain point where it turns back and it comes back to the point. And at this point here, the time is equals to pi over 3, as shown here. Now, to find the value of t at A, at point A is at instantaneous rest. So what we need to do is to differentiate the displacement with respect to time. So 2 sine 3t, you differentiate this, sine becomes cosine 3t. Differentiating 3t gives you 3. 3 times 2 gives you 6. So 6 cosine of 3t. So at instantaneous rest, okay, the velocity is 0. So 6 cosine 3t is 0. Dividing both sides by 6, cosine 3t is 0. How to get pi over 2? If you remember, okay, where is the cosine graph equals to 0? First time round, it occurs at pi over 2. Then the next time round is 3 pi over 2. So hence is at pi over 2, the time t is equals to pi over 6. Now, last but not least, okay, find the acceleration. So from our velocity in the previous portion, the velocity was given by 6 cosine 3t. To get acceleration, you will differentiate velocity. Cosine differentiated gives you negative sine of 3t. Okay, the 3 you differentiate is 3t, you differentiate, get 3. 3 times 6, so you get negative 18 sine of 3t, which is shown here. So we have pi over 6 from the previous part 2. You just substitute into this negative 18 sine of 3t. You get the acceleration is negative